Hey guys, my name is Juliet Leegee and I'm going to show you all how to do the comparative effectiveness assignment. So just a quick overview of objectives for this assignment. What is a comparative effectiveness study? So a comparative effectiveness study helps to determine the benefit and comparative advantages of two different processes. So how does this help us as future administrators? It can help us determine the value of an intervention and also answer that what works best type of question. Okay, so let's quickly go over the instructions given to us for this assignment. It says to use the table provided and identify which two patients in the following table could serve as matched controls for the cases. The cases received the intervention while the controls did not, and the blanks on the chart indicate patients who did not fall during the given time period. We are going to match the cases based on the age and select the possible controls randomly using the lowest random number provided, which is in the rightmost column of that chart. We will then show a Kaplan-Meier survival plot of patients with no falls for the follow-up period provided. Then for part 2 of this assignment, we will answer questions based on the decision trees provided. So what exact tasks are we going to have to fulfill in doing this assignment? So we're going to have to find the standard deviation of the patients on the chart. We're going to then have to find the intervals for the two cases highlighted in yellow. And then using those intervals, we're going to divide the patients into two groups, select the controls, and then find the percents of patients that have fallen and the percents of patients that have never fallen, and then we're going to use that to create a graph. Okay, so on this slide you can see the chart that we have been provided by our professor. The two cases highlighted in yellow are our case 1 and case number 2. So we're going to need to find the standard deviation of all the patients in this chart. So you can do that in Excel by doing the equation equals STDEV and then highlighting all the ages in the chart to get that standard deviation. And you should find that the standard deviation is roughly 8.9. Now, knowing the standard deviation, we're going to try and find the intervals for the two different age groups for case number 1 and case number 2. So if case number 1 has an age of 65, we're going to find the up and lower bounds of that number by adding and subtracting the standard deviation. So we're going to find when we take 65 plus the standard deviation, it's going to equal 73.9, and when we subtract the standard deviation, it's going to be 56.1. And when we do the same thing for case number 2, we're going to find that the upper interval is 92.9 and the lower one is 75.8. The controls were selected as the two patients in each group with the lowest random number. Pictured here, you can see that it's patient 4 and 6 and patient 8 and 9. So now we have broken up the patients into two groups. One will be the controls and one is going to be the two cases that were highlighted in yellow. So pictured here in green, we have the two cases. This chart shows the number of patients at risk of falling and those who did not fall. This is going to be patient 1 and 3 and they are at risk of falls. So then we're going to do the same thing for the group of controls pictured here in blue, which you can see there are 4 cases here and they are all at risk of falls. Here you can see the Kaplan-Meier plot for the cases and the controls over the period of 4 months. I created this graph by selecting the two charts I made in the previous 2 slides and using the graph function on Excel. So moving on to part 2 of this assignment, we're going to try and answer some questions based on the decision tree provided. So we're going to try and answer what would be the expected length of stay for each of the two clinicians pictured in the decision tree, as well as what would be the expected length of stay if each clinician was to take care of the other doctor's patients. Using Excel, you're going to want to make a chart by following the probability of each node in the decision tree and finding the length of stay associated with each option. At the end of the chart, using the product function, you're going to want to multiply the probability and the length of stay for each option. And then at the end, you're going to add up all the calculations to get your expected length of stay using the sum function. You should find that the expected length of stay for Dr. Smith is 3.64 days. So you're going to follow the same steps using the decision tree for Dr. Jones. You're going to do the probabilities times the length of stay, and then you're going to add up all the probabilities and length of stay calculations, and you're going to get that the expected length of stay for Dr. Jones is going to be 4.76 days. So next we're going to try and answer how long the expected length of stay would be if Dr. Smith sees the patients of Dr. Jones. We're actually going to do that by taking the probability calculations of Dr. Jones and pairing them with the length of stay of Dr. Smith. So you can see that in this chart. So you should find that the expected length of stay if Dr. Smith were to see the patients of Dr. Jones to be 4.295 days. So you're going to do the same thing in order to find the expected length of stay if Dr. Jones were to see the patients of Dr. Smith. You're going to take the probability calculations from your original Dr. Smith chart and pair them with the length of stay days from your Dr. Jones chart, and then you should find that the expected length of stay is 3.74 days. So just to quickly review, the expected length of stay for Dr. Smith was 3.64 days. For Dr. Jones, it was 4.76 days. If Dr. Smith were to see the patients of Dr. Jones, it would be 4.295 days, and if Dr. Jones were to see the patients of Dr. Smith, it would be 3.74 days. So just in case you guys wanted some additional resources, I put here the links of the Teach One assignments that really helped me the most. Overall, I hope my video helped you complete the assignment. Thanks for watching.